Hey, this is Rick Husey. I'm here with Tim Smith, and today we're going to be talking about DOCSIS PNM and how to target and prioritize near-home and in-home issues. We'll be right back. Hi folks, again this is Rick Husey from Z-Quorum here with Tim Smith, network engineer here at Z-Quorum. And we didn't do a Tech Tuesday last week. I was not available. I was busy growing a beard. So that took a lot of energy. But this week we're back, and Tim and I are going to be talking about in-home and near-home issues and how to target those with PNM. 2 weeks ago we talked about correlation groups, looking at common impairment that might be impacting multiple modems. And we talked about how you can find that in a pre-equalization analyzer tool. And that's important. But something we mentioned at the end of that was that it's also very important, as we looked at that, to really also be focusing on in-home and near-home issues, right?
Yeah, definitely, Rick. Most of the noise, and anybody who operates a cable plant will understand that it's near-home and in-home issues are where the majority of the noise on the upstream is going to be coming into their plant. These are people who've done their own home wiring or their own home networking. You know, they've push the cable together with their fingers. You know, they're not using factory-made cables or things like that. Bad fittings, bad splitters that are in backwards.
Did some gardening out in the yard and said, "Oh, I nicked that cable, no problem. Electrical tape will repair that."
Exactly. We have a lot of that. Or I need this to go a little bit further, so I pull it around the corner of the house, and bend it and bend the cable past 90 degrees, things like that. So. In-home and near-home issues are going to be where the majority of the noise on the upstream is. And
obviously that's the area of your cable plant where you don't spend a lot of time. I mean, they're generally out in their hardline plant fixing things all the time, finding things, and they're maintaining that much better than they can, let's say, certainly in the customer's home or just outside it at the drop.
Exactly. They're most of the time, once the modem's installed, it can kind of be a set it and forget it thing. It's done. I've got it in the plant. That's operational. The customer's happy, and the modem is chugging along. But behind the scenes, there could be something that's going on that the modem is compensating for. That pre-equalization by design helps the modem take care of, and it's it's answering the request that the CMTS is saying, hey, I need you to adjust your signal this far to get over this problem, and modems are doing that. So
today, by the way, if you're watching live, you can ask questions. Just go to the chat box in YouTube and you can type in a question. We'll try to get to it at the end of the broadcast if we see it at that point. So again, in-home and near-home issues, and as you mentioned, it's kind of important also on this because in addition to that maybe causing some issues for that one customer, it can also cause issues for everybody on that upstream because it can be letting in noise if there's ingress in some source of noise.
Yes, that's really the underlying problem, is that noise is compounding. It doesn't cancel. Right. So if home A is letting in a little bit of noise, and home B is letting in a little bit of noise, and home C is letting in a little bit of noise, and home D's really got to jack up his signal to get over those noise floors. So
and it just all travels all the way back to the CMTS.
Correct.
Yeah. Okay.
Correct.
All right, let's take a look at some screenshots from pre-equalization analyzer here, and you can kind of walk us through these.
Okay. A lot of times we'll get an affiliate who'll say, okay, I've got all this information in PNM. What do I do with it? Where do I start? And the easiest way is to actually look at my red modems. Now, on the main dashboard of our PNM tool, we actually can look and see that we actually have the worst modems, and they're grouped right up on the dashboard to start with. So if you're coming in first thing in the morning, you want to know who the worst modem is of the last polling cycle, this is where it'll be listed.
One of the things that developers have done in pre-equalization analyzer over time, if you've been on the product for a long time, is try to present a lot of information, make it available to you so that it's, in this case now, in what we call a business intelligence dashboard, so they can see various things on here. And one of those is this critical modem action list.
Yep, critical modem action list. It kind of sets you up for where you can start your day here. And you can go ahead and look at the worst modem on the list. There's a couple of ways that you can actually go about doing this. And the reason that you end up with a critical modem action list is actually out here to the right is the work orders tab or work orders column, where you can actually create a work order to address the worst modems on the plant. And that's one of the features inside of here. But let's go ahead and look at what the first, what we're looking at as far as the modem.
Yeah, let me go over that real quick because some people may not be aware of what that's for. So if they go in and click that work order, and we're looking at screenshots here because this is a live system, so we can't actually do this, but that will pull up a list of technicians that are in the system, and the technicians can have the Nimble PNM app.
Exactly.
And it will send the work order to that application.
Right. It'll send it to their smart device. It'll show up in their work orders queue, or it can be added to the general work orders queue, and then it becomes when somebody opens when they open the work order, whoever's nearest to wherever that geolocation is, that'll show up in their queue. This is the next thing to be fixed.
Right, and they can go in there and make notes and take pictures and say that they've completed it.
Exactly. Exactly. And then that'll show up in another report that can be run in PNM that says completed or repaired work orders, or repaired modems. And so you can actually bring that up and it'll say fixed work orders list.
Nice feature, yeah.
So, all right. So after we've looked at the widget, the other way that you can actually do this is you go into the data tab under the detail view. And the detail view is what most people think of as the map view. You bring up the detail view and you've got the data tab. Go ahead and click it, and you can highlight the red modems and say, show me the red modems, and then you can sort them by what is the worst of the worst. In this case, we're looking at two different columns here. One of them is main tap compression, the MTC. This is how hard a modem's working, how much of its internal resources it's expending to get over the problem. You want this to be less than 50% of his available resources. So less than 0.5 would be considered better. It's still not great, but as you approach that 0.5, the modem will turn to red on his main tap compression.
And again, just something to keep in mind here is that when this modem is going red, it's because it's the pre-EQ information that's making it red. So this customer may have a perfectly fine experience because pre-equalization is compensating for these issues, these micro-reflections or whatever it is that's causing this. But in this case, you want to attack these things because this could very well be a problem in the future.
Right, and it's just going to get worse.
And it could be letting in noise as well.
Exactly.
Even though the customer has a good experience, there could be ingress from this.
Exactly, and that affects everybody who's sharing that upstream with them. So as we're looking at the two columns, we've got main tap compression, and then we also have micro-reflection level. Micro-reflection level is what makes the little icons on the screen green, red, or yellow. So those are defined on the main screen. But if we're looking at this first modem, and we highlight him and bring him up, we can see that this modem, number one, is intermittent. It should be available to bind itself on 3 upstreams, and it's only able to reach 2. And we're looking at a common in-home issue of right around 80 feet. Now, and
you see that from the TDR there.
From the TDR column brings us up to, we're looking at an 80-foot issue. Likely this is going to be an untapped piece of cable that's acting as an antenna, or an open splitter, or I would think that with the fact that all 3 of these upstreams are not locked in, that we've got something open to the environment, possibly a cut, or a break in the cable. So we can actually tell that, not that it's a break in the cable, but we can see that it's open to the environment when we look at the screens that show where we actually are. Hold on. Thought this was up sooner. There we are. The 2 TDRs that are listed here are both showing as opens, and those are on the 2 available channels that we're looking at.
So this is where we've drilled in.
Yeah,
we scroll down to the charts.
We scroll down to the charts, and once again, remember that the charts on the left are the in-channel frequency response. This is what the CMTS is asking the cable modem to make an inverse signal so that it comes back to the CMTS as flat. So we can see that on the first frequency and the last frequency that we're looking at these steep, severe changes in in-channel frequency response. The in-channel frequency response should stay between 1 and -1, so it should have a delta of 2.
To be in that green area.
Yeah, to be in the green area. If we look back on the charts, here we go. The in-channel frequency response on these is both 11, so we're well outside what we would consider good range.
And it's in a partial mode, so we don't have the the third channel.
And we don't have the third. And like I said, if the third can't even lock in, we've definitely got a modem that's causing problems.
Yeah.
Once again, the chart to the right is the digital taps. We can see that the elevated tap 9 means, and we're above the reference level. We can definitely see that this is going to be an in-home or near-home issue. Remember, taps 9 and 10 are what we consider to be in-home, near-home, and that is defined as from the drop all the way to any extended wiring in the house.
And again, the main tap compression, when we talk about the main tap, that's tap number 8.
Exactly. How hard is he working?
And it's and tap 8 is normally where you have the most of the energy should be going through, but you've got these other taps that are being elevated to compensate for that. So that's where you get your ratio in main tap compression.
Exactly. So as we go through and start looking at these signals, we can see that it's being asked to ramp up and overcome a severe noise issue. This is the channel that isn't there. So we're saying that we probably, in my opinion, we probably have a break or something in that cable where this signal can't even be found. And we're actually also looking at a very similar, the signature is very similar if we were to lay them on top of each other at the same frequency. So it's something that's ramping up to get over a big noise floor.
And then a nice feature here is if the modem is full band capture capable, we actually throw the, and this is on the downstream, but we show the downstream spectrum that is being captured.
Exactly.
The last capture that we got on that.
Exactly. And so full band capture capable modems basically turn those FBC modems out in the field into spectrum analyzers for the downstream.
Yeah, so it's nice to be able to look there and see what issues you have. In this case, it's automatically identifying something that looks like a wave.
Yeah, we got a standing wave early in the signal, and then we got a little bit of an amplitude. But for the most part, we're concentrating. PNM is designed to concentrate on the upstream. The downstream is a nice feature that we're starting to bring in more and more of as the product gets developed further.
And I'm looking there. It looks, I guess maybe they've got a section out where they don't have some channels. Maybe is in an LTE area, maybe. So you're seeing a little spike there. Maybe they specifically don't have channels there.
Right. Exactly.
Yeah. Interesting. So so it can be overwhelming for folks when they come in, and especially when they first get pre-equalization analyzer installed, because everything on their plant looks okay. They've had pre-EQ turned on, and then they get this pre-equalization analyzer turned on, and they've got red modems everywhere, because again it's showing issues that are kind of hidden or masked by pre-EQ. So it can be a little overwhelming. So what this gives them is a way to kind of methodically target their worst modems.
Exactly. This will let you target the worst modems, and the majority of those are going to be in-home, near-home issues, as we stated. So the modems themselves are lined up for you. Here's my worst modems. There's a couple of other reports that can be run in the product. If you look at the red modems, you can break it down by node and see where those are. You can then take the data from the data tab, those columns, and you can actually export that to a CSV file. You could sort them by geographical, like if you're going to know your plant, so you're going to know all the modems that are on Elm Street, and is Elm Street near Oak Street, and can I send one technician to handle these 5 modems? Can we make appointments and get these in-home issues taken care of?
Yeah, and that's an important point, because pre-equalization analyzer is a DOCSIS proactive network maintenance, or PNM tool, and that's really how it's meant to be used, which again, as you see all these red modems, it doesn't necessarily mean that your customers are having a bad experience. There could be ingress coming in from these points as well, but it gives you the ability, while these customers still are having a good experience, to go proactively schedule maintenance to repair these things. So rather than waiting, if you didn't have a PNM tool, for example, then suddenly that crack in the cable gets worse, and then suddenly you got a customer calling because they don't have good service. So this way you can proactively get these things fixed. Reduce the number of red modems, and that has the benefit of reducing ingress in your plant. And then also, like we discussed 2 weeks ago, if you're looking at the correlation groups, a lot of times it's hard to see those correlation groups if you've got a lot of in-home issues, because that will kind of hide, in a sense, or muck up the algorithms that look at the correlation.
Exactly. You can have such severe in-home issues that an external issue is hidden.
All right, we'll stand by here 1 second. Doesn't look like we have any questions right now. If you have questions, if you're watching this recorded and you have questions, you can still go ahead and submit something on that chat area right there, and we'll take care of that. Remember to, if you like this video, go ahead and click the thumbs up, give us a like there if this has helped you out. And if these kind of videos are helpful to you, go ahead and subscribe. Be sure to click the little ring the little bell, click the little bell icon, and you'll be notified whenever we do a live broadcast or whenever we post any kind of video. You'll be notified at that time. So thanks, Tim. This was very helpful, both when we did the correlation groups and then today. And what I'll do is I will go ahead and post a link to the previous video on correlation groups, maybe as the first comment in this video, because we did have an issue there. I didn't realize when we were looking at the screens on the screen, everything was kind of expanded, and you were pointing to things sometimes that were not on the screen.
I understand.
Yeah, so we went ahead and kind of redid the screenshot so that you can see that now. So, but also you may not have seen that video, and I'll go ahead and post that in the comments, a link there, so that you can find the prior video very easily on that. So next week, I'm going to be with Kevin Mitchell from Alianza. Kevin and I are going to be talking about options for service providers in providing voice over IP service. There's ways that you can do it. Obviously, you can buy your own switch and handle all the numbers and 911 and all of that. Or you can look at a cloud-based solution, and we're going to be talking about some of the advantages of that and some of the opportunities that you would have with offering commercial voice. There's a great revenue stream there, but both in residential and commercial voice. And you can do all of that in a hosted model where it's really pretty much turnkey, and all you have to do is market the service. There's not a whole lot that you have to do on your own. So again, next week, next Tuesday at 3 o'clock Eastern Time here on Tech Tuesday, I'll be talking with Kevin Mitchell from Alianza, and I hope to see you then. Thanks, Tim.
Thanks.